This is question 18 of the Natural Sciences Admissions Assessment Specimen paper. So in this question about probability, we have two six-sided dice. One is fair and the other is not fair, because it lands on six with a different probability than the numbers 1, 2, 3, 4 or 5. And when we roll the dice, the probability that we get a total of 12 is an 8. We want to know the probability that we get a total of 2 when we roll the die. So first of all, we've got our dice here. One's fair, one is not fair, and they're numbered 1 to 6. So first of all, we're going to come up with so we're just going to call the probability that we roll a 6 on the not fair dice something. So let's call that P. So 2 is the not fair dice. We've just labelled them here so it's easier to see what's going on. Because the fair dice is quite straightforward. The probability of rolling any number is the same because it's fair, so the probability of rolling any number is just a sixth. So we're going to focus on dice 2, and let P be the probability that we roll a 6 on dice 2, so the probability of getting a 6 is different to everything else, we're told that here. So now would be a good time to pause the video and see if you can work out the probability that we roll a 5 on dice 2, or a 4, a 3, a 2, or a 1. Well, the probability that we roll one of the other numbers is just 1 minus P over 5. If you can't see why this is, you could remember that the total probability of all the events is 1, so we need to come to 1 eventually. So if P is the probability that we roll a 6 on die 2, then we have 1 minus P left to get to our 1 in total. And we have 5 options, 1, 2, 3 or 4 or 5, which are all equally likely. So that is why we divide by 5. So you can see this if we add up the probability that we get 1, 2, 3, 4 or 5, we could add this up and it would be 5 lots of this, which would be 1 minus P. And if we add the probability that we get a 6, we just get 1, because 1 minus P plus P is just 1. And that makes sense because the probability that we roll 1, 2, 3, 4, 5 or 6 is certain, like we roll one of them, because what else did we roll? So that's why we get 1 minus P over 5 here. So now we're going to look at the statement that when we roll the die, the probability that we get a total of 12 is an 8th. And let's think about what we mean by a total of 12. So you could try out some numbers of rolling on the dice and work out what we could have to get 12. And you'd find pretty quickly that the only two numbers which work are 2 sixes. Because if we had a 5 on one dice, then we'd have to have a 7 on the other dice. And we don't have a 7, so it must be 2 sixes. Okay, so we know that the probability that the total is equal to 12 is 1 over 18. And the probability of 2 sixes, well, that's the probability of a 6 on the fair dice, which is a sixth, and the probability of a 6 on the second dice, which isn't fair, which we've called P. So it's going to be 1 sixth times P, which is P over 6. Now, this is nice because we can rearrange it to find P. So P equals a third. And the next thing we're going to do is consider what happens when we have the total equal to 2, which is what we're trying to find. Well, the only way we can get 2 is if we have a 1 and a 1. Otherwise, we'd have to have a 0 on one dice, which we can't have. So we want the probability that we have 2 1s, 1 on each dice. So why don't you pause the video and see if you can work out what is the probability that we have 2 1s? Well, we know that the probability of having a 1 on the first dice, the fair one, is a sixth. And we know that the probability of having a 1 on the other ones is 1 minus P over 5, because we worked that out up here. So we're going to multiply these things together to get the probability that we have 2 1s. And when we work this out with P is equal to a third, which we worked out up here, we should get that the total equaling 2 has a probability of 1 over 45. And so our answer is B. So let's just have a look over what we've done. So we knew some things about the probabilities of what we had. So we called P the probability that we roll a 6 on die 2, so that we could then work out an expression for the probability of rolling something else on die 2. We chose it to be the probability of rolling a 6, because that's the one that's different because of this statement here. Then we thought about what it really means for the total to be equal to 12 and 2, because there is in fact only one possibility for each of these, which makes it a lot easier to deal with. So then we just found a numerical value for P and substituted it in to get our answer.